Hello, sir.
Yes, ma'am.
Yes, sir. We'll start. I'll just say a word and you can start, sir.
Okay,
So,
sure.
good afternoon to yes, sir. Good afternoon to all the participants. I welcome you all to the second day of workshop on DevOps 101, Build, Ship, and Scale Smarter. I welcome our resource person, Mr. Kedarnath Grande, Senior DevOps Engineer, TransUnion, Hyderabad, Telangana, India, for this wonderful session. And today's session is about Git fundamentals, branching strategies, Git flow, CI, and CD. Now, I'm very delightful to hand over the session to Mr. Kedarnath Grande. I welcome you, sir, and you can start the workshop now, sir. Thank you.
Yeah, thank you, ma'am. So okay. Hi everyone. Before we start the session today, was asked a question yesterday regarding a demo for CI/CD. So I just spinned up a quick demo so that I can just present that for first few minutes. Okay, so I'll just go through this. This is my GitHub profile. You will know what GitHub is and what Git is today. So don't concentrate on that right now. So there is a repo. It's basically a folder, and you have a Python application. Um, this is app.py. There is a Docker file. You will know what Docker file is and what it does in the next session. Um, okay, so I just have the exact same folder in my local. Okay, this is CI demo. Um, and let me just show you the app.py. This is just a simple Flask application where it just prints hello world when you run the application, right? So in GitHub, as I said, there are many tools, right, to perform the CI/CD operations, pipelines, whatever it is. So one of the tools, apart from Jenkins, is GitHub. Um, So in GitHub, when you have any repository, you'll have something called actions here. Okay. When you add a folder called .github, adding a dot in front of a folder name makes it hidden folder. Okay. So if you just go to terminal, I'm in the CI demo folder only. So if you do ls, you can't see the .github folder. Why? Because there is a dot in front of it, right? If you want to see it, you have to add a in front of it so that you can see the dot hidden files basically, right? In that .github, there should be a workflows folder. In that there is a main.yaml. Uh, this file, okay, I'll just show it here so that it's on white background and you can easily see it, right? So this file tells GitHub what it needs to do and when it needs to do something. Okay. So the name of this pipeline which we are creating is CI/CD pipeline. The on keyword, what it does is on push to this branch, main branch. So in the code, this is main branch. Okay. There are no other branches. Branches is only main. So what we are telling basically in the first few lines is, in these lines is, this needs to be triggered. This particular steps or jobs need to be triggered whenever there is a push done on the main branch. Okay. So in the jobs, we have several jobs here, test, build. I'll just make few edits before running it. Okay. So I just pushed that change into Git. I'll walk you through all the Git commands in this session today. So what it does is there is a test. Okay, let me just show the actions page. You can see the pipeline is triggered because I pushed a change to the main branch. It's triggered just now and it's in progress. While it's in progress, I'll just walk you through the code, what it does, what the jobs do. So this is a test step. What it does is it will check out the code, all this app.py, whatever application code is there, it will check out into that Ubuntu system. It will run a Ubuntu system in its own virtual space. It will get the code there, checking out code in the sense it will copy the code into that system, and it will install Python. It will install all the software mentioned in the requirements.txt file. Since this is a Flask application, we are mentioning Flask here. That's why it will install the Flask application. Okay, and it will. It's also installing PyTest. You can alternatively mention PyTest here, or you can add the PyTest here only. It will install that. So I just mentioned it outside so that there are so that I can show that there are two ways of installing files. I mean softwares. And PyTest command, it will test the application. So this is the test job. Regardless of it is success or failure, it will go to the next step now. Okay, this is a build step. It also runs on Ubuntu. It also checks out the code. Now it is logging into a Docker hub. This is a location where you can store images. What is Docker image and all, I'll tell you tomorrow. But just understand that it's a location where you can push your application in a compressed format, like a jar file or a Docker file, Docker image basically. So Docker Hub is a platform where you need the account, your account basically, and you need a user ID and password for it. So for your code to push that any files or access these files, it needs to have the credentials to log in and do that, right? So you need to give that username and token for it, and it's saying secrets dot Docker Hub token, secrets dot Docker Hub username, right? Where that secrets are, I'll just show it. But you shouldn't put your name and password in the open like this, right? It's a public repo. Anybody can see your credentials and they can just hack your account, right? So I'm just giving the image name. I'm running a Docker commands. Okay, so I can see that the workflow is already completed. In the workflow, test and build, two steps we mentioned right in the YAML file. Test and build, these are both triggered and are successful, right? So I didn't have any repos here. This is a new account I just created for this demo. Okay, when you refresh it, you should be seeing a image pushed into that repo. So the image name is my image, as you can see here, right? So that's there. Let me just delete it and we'll do something again. My image, get delete repository forever. Yeah, so regardless of whether the test is pass or fail, we are building the application. But in enterprise scenarios, you should have, why are you running test? To see if the code change is working properly or not, right? So the build step should run only when test is success. So that's why what we do is, oh, not here, just so that's why we have something called needs, and we mention the step name here, like job name here. And if needs dot job name dot result is success, only then run this, right? So let's tweak something and make this test a failure. Okay, so we'll go to in test.py. What does test do? I said right, it just runs a test.py. It's another Python file. What is it is doing is it is checking for the response status code if it is 200, and the response data has hello world, right? So let's just remove the world here. So it will just print hello, and since the application is actually printing hello world here, this test should be a failure ideally, and this step should be a failure. So test will be a failure. So since test is a failure and this condition is not being met, this build should not run and image should not be pushed to the Docker Hub. right? So I'll just do the commits. Oh, I added the same commit name. That's fine. Yeah. So when you go to this, another pipeline is triggered. Okay. So let's see what's happening. So now it's showing this dependency here. If you can see between the jobs, why? Because we did that um, need step and if condition. We mentioned the other job name here, right? It is visually showing a dependency between the two jobs basically. So as expected, the test is failure. Why? You can just click on it. You can see that assertion error. Basically, hello came instead of hello world. That's why this is a failure. Okay. Um, and build it didn't even get triggered. This job was skipped. Why? Because test is a failure and there is a dependency for test to be success for the build job to run. So this is basically CI. What I said, any code development or code changes being merged to a branch or your code repo, like CI demo is my code repo right now. Any changes, code changes being pushed to that code repo and running tests on it and validating it all comes under continuous integration. Okay. Uh, but the continuous delivery or deployment, it's so now you are just building a image here, right? You are not deploying the application. You are just running a test here, but you are not actually deploying the application in a production environment or test environment or whatever, right? So CD deals with the deployment of the application. You have pushed the image into Docker Hub. Now, if there is a another step called deploy, I have noted that steps as well. Let's say the step name is deploy, and you need a server basically to deploy something. It should run on that server, right? I don't have a server right now, so that's why I just skipped the CD part here. So basically, you give the SSH credentials to this step, okay, and you do Docker commands again. This is Docker run command. So you are basically taking the image from the Docker Hub image pull, right? I'll go through all these commands in next session, like day 3 session containers is there, right? You will understand all that there. Just understand that you are doing a pull on the image which you have built in these steps, okay, and you are running the container. This is CD, and the code changes, like pushing the code into the repo, processing that code, building an image or jar file out of it, and maintaining it in some artifact repository like Docker Hub is the CI part. I hope the question is answered from yesterday. I don't remember the name, sorry. Yeah. Okay, fine. So let's get back to our presentation. Yeah, so today is Git and GitOps. And we'll understand what Git is, what are the differences between Git, GitHub, GitLab. All these Git types are there, right? There are so many. What are they? What are the differences? Why are there so many, right? So we'll understand all that. And there is something called like DevOps. There is GitOps, and there is MLOps. There are several ops, right? So we'll understand today, since we are dealing with Git, we'll understand what GitOps is today. Okay. So yeah, what is Git? Can anybody speak up and say what Git is? We have just seen some pipelines in the Git, and I have also mentioned the answer. If anybody listen to that, I hope some answers popping up.
It's a version control system which tracks the
Awesome.
code
Okay.
changes.
Nice. So I got a confirmation that my people are listening to me. Okay. So yeah, in today's, I mean, world of software development, collaboration is a key, right? Collaboration in the sense, coordinating with your team members, a collaboration in terms of software code or whatever it is. Collaboration is key, right? Whether you are working solo or as a part of team, keeping track of changes, managing versions of code, and ensuring that everyone is on the same page can quickly become chaotic. see, if we have only few lines like this, then it's easy, it's fine. You can just talk it out with your team, and they can track changes. Oh, I just changed this dependency, I added a dependency. But when there are hundreds and thousands of lines of code and repos, not just one repo, in enterprise there will be hundreds of repos. Okay, so in such cases it will be really hard to keep track of who is changing what and what change broke the system or application, right? So Git is a tool that was designed to solve many of these challenges, right? It provides solutions to common problems faced by developers and teams regarding version control system. Okay, so Git is a free and open source distributed version control system designed to handle everything from small to very large scale projects with speed and efficiency. Let's just take a look at what problems does it solve. It will keep track of changes. Okay, Git records every change in the code base. I can just show you that as well. I need to skip this. Okay, so where is it? Yeah, this it shows that it's a change that was made 5 minutes ago, and there are 8 commits previously before this. Right, if you click on that, you'll see everything is tracked. Yesterday I was preparing this demo, so yesterday these many commits were there. Today I just changed in front of you, I removed the dependency, added the dependency, so these changes are right. So basically who is doing what change and what message they are adding in every commit. And if you click on let's just click on this, right, it will show you what is changed. So red indicates removal, okay, and blue or green it indicates adding. So it's showing this minus symbols, right? That means this line was removed. Okay, if you added any lines, I added the lines again, right? So it's here. So you added these lines, right? It's green, and yeah, and this was also edited. See, you have removed this line and added this one. Basically you have changed that line to this. So every change is basically tracked. Okay, okay, so that's the tracking thing. And the collaboration, Git allows developers to work in parallel by creating branches. I'll show you what branches are. Each developer can work on their own branch without disturbing each other's work, basically. And they later merge their work into the same main project from where you will build your applications. So that's why it's called main. When someone asked you to add some login feature, let's say, to your web application, you just create a branch like feature slash login something. You add that code, and then once you are done with your code changes, you are sure that it's working, your unit tests and all that testing is done, then you just merge it to the main branch. And whenever these pipelines are there, right, whenever there is a change detected in the main branch, it will run the pipeline and it will trigger that cd pipeline to deploy the application. So Git intelligently merges changes. It helps developers resolve conflicts. If 2 or more changes touch the same part of the file in the same line, then there will be it intelligently notices that, and it will throw a merge conflict. So user needs to go and manually resolve that conflict, because Git can't decide what part of code it needs to preserve. I'll show that as well in this demo. And there is a versioning and rollback. So let's say your new change or new commit is breaking something. Since you are keeping a track of all the changes, you can just roll back to the previous version, so that the change which is breaking the application can be reverted or removed, right? And there is another thing called distributed development. Okay, so now I have committed my code in this Git repo, right? In the repo which I showed just now, CI demo. So let's say that server goes down, GitHub is crashed. So what happens to all the code, right? Everybody is merging changes there. Um, your code is not actually lost, because in every local system of every developer, in their laptops, you still have the code preserved. And if their laptops go down, one or two, the GitHub is there, So your code is basically preserved in different locations, so that if even if one or two devices go down, you still have a copy in other systems. Unless every system goes down, you don't lose your code, right? So, and you can experiment with new features. Basically, this is again the same thing as collaboration. You can have n number of features, and people can work on different experimentations, like new features. How does this work? How does your application behave with new changes without disturbing the main application? You can do all that. Okay. And remote collaboration and sharing. Obviously, people can work from home now. They can work on their changes, and they can just push the code into Git. Everything can be done remotely as well. So that's all the one of many of the problems that Git solves today, right? So I'm telling Git sometimes, but I'm also talking about GitHub sometimes. So what is the differences between these two, right? So basically, Git is an open source software. Okay, it's a CLI tool. Now you saw all these commands, right? Git commit, Git add, Git push, whatever I've been doing here. It's Git. It's a CLI tool. You install that in your local system. Okay, that's a open source software. You don't pay anything for it, right? It's maintained by Linux created Git, and it's any updates or any bugs removal or new features adding, all that is maintained by Linux only. So version control system is installed locally. I'll show you all that, what it does, what change, how is it tracking all the changes, all that. Okay. And there is no user management feature. Obviously, I don't have a UI here. I'm just working with the CLI tool. Git doesn't have a UI. And alternatives to Git, the CLI tool, are Mercurial, Subversion, and CVS. These are maintained by different people, by different companies, maybe, or different communities. And coming to GitHub, this is a paid service. Yesterday in the periodic table, I showed a category called freemium, right? So this is nothing but that. It's a free thing until certain limit. When you cross that limits, you have to pay for it. So GitHub is developed by Microsoft, and it's maintained by Microsoft. GitHub basically internally uses Git. Okay, they have built a user interface on top of it, like this UI. They have built it on top of Git, right? So GitHub is Microsoft's product. Since Git doesn't have UI, they just built a UI, did some fancy things, and added some new features, and they made it freemium product. Okay, so they have built-in user management feature. You have when you are maintaining a company, you need credentials, right? In GitHub, you need to create your account. I have created my account, right? So similarly, you have user management is a feature added in GitHub. And when you are maintaining a company, you can have the employees user management as well, so that only private, this is a public repo, means anyone can access it. If there are any private repos, you can allow only a certain people or certain number of people to access those repos. So all these comes under user management. So that is there in GitHub. Alternatives are GitLab. I think GitLab is, I'm not sure who is maintaining that. Yeah, and there is Bitbucket. Okay, so these are all whatever has UI, these GitLab, Bitbucket alternatives, they are also freemium products. They have a certain limits. Within that, it's free. If you cross it, it's a paid service. Now, setting up Git and GitHub, you just go and create an account normally, go through that process and do it. Since I have an account already, I can't show you right now. And you also can, add extra features like two-factor authentication. Like when you type in the username password to log in, it will ask you for a authenticator code, which authenticator you can install in your mobile, and it will be every few seconds it will refresh the 6-digit code, and you have to enter that code to authenticate again, like two-step authentication, right? So that's there. Git CLI, if you are on Linux, you have to go to, not only on Linux, it's Git SCM, something will be there. Yeah, Git SCM download. So this is a Git open source, which I said. Depending on your operating system, you have to download these. You can just install them and start running. The verification command, like if it's installed properly or not, you can type. Okay, let me just clear this, maximize this. Git -hyphen version, and you can see if it prints the version, then you are good to go. Okay, so that's one thing. Initial configurations. I think yeah, initial configurations, what it does is there are some commands like, okay, I'll just show git config -list. Okay, so this is a configuration. I'll just remove this for now because I don't want to show it. So if you want to configure your git initially, so you can just do git config -global user dot email equals to your not equals to, you can just type in my email something, your email address, if I can type it properly. Yeah, this is one command you need to use, and the other command is user dot name, basically your name, something like that. Why this is needed, why these git config commands need to be executed? See, we are talking about git. It needs to track who does what, right? For git to know who it is, you have to tell them tell the git who you are, right? So that's why you are adding your name and email address, so that whatever changes are done from your system, you are giving your identity proof, something like that. So in the command just now, we just saw git config. Okay, I'll just note these commands in a new file so that I config hyphen. I hope you can see the letters. Is the font too small? Oh, okay. So what does it mean by global? So you can have multiple repositories in your local system, right? They are just folders, right? So if you are adding this global, then you are telling it that for all these repos, this is my identity. If you want a separate identity only for a particular folder, you have to use --, local. Okay, that makes sense, right? Yeah. So that is setting up git CLI and initial configurations. Okay, now we come to basic git commands. So whenever you are working with git, you must know all these commands. Okay, there are advanced commands as well, we'll cover them as well, but these are the core commands, and without these you can't even get started, right? So git clone. So let's just okay, I'll just close this. Let me create another folder here, or maybe outside practice folder, git demo. Okay, and okay, it's not showing up here. I just drag out, don't save, set as others. Okay, git demo, and I'll just open the terminal here. Now if I want to clone this particular repo again, I'll just go here. There are several ways to clone a repo. HTTPS, it gives you a HTTP URL. You can use SSH keys, and you can just grab and this command and execute it. Okay. But for this to work, you need to have SSH keys in the settings. Oh, I'm sorry. I just didn't. I skipped this part, right? In main.yaml, in secrets, docker hub.username, how this is resolved, I just skipped. So in settings, you have something called secrets and variables. You go to actions, and you can add your tokens here, new repository secret, and your secret name, and that secret password or name or whatever it is. So once you have these here, you can just access them using secrets dot that name, whatever the secret name you give. Yeah, I told I cover it, but I just skipped it. Fine. Um, yeah, that's the setting. You can clone your repo using any of these ways. For now, we'll just do HTTPS. Okay. So in the your folder, whatever it is, so git clone, and that URL which you copied, it will just clone your repo from here into your local system. It's that easy. You have all the folders here. You have all the branch information. Okay. Okay, I'm not inside that folder, that's why it's throwing that error. I'll just go to CI demo. Now if I do git branch, it's showing that it's in the main branch. Fine. So because there is only one branch, it's showing that all the commit info, everything will be cloned. So that is git clone. Okay. Okay, maybe I'll just repositories. I'll create a new repo here. Okay, this will be git demo with AP. I'm typing all this because that name should be available. So as this is a public repository, it shouldn't conflict. The name shouldn't conflict with other, you know, others repo names. So you can add some description here. For now, I'll just add a README file. Okay, creating a new repo can be done in two ways. One is this, like from UI, you can initialize the repository here itself, or you may already have some code in your folder and you want to push it later all at a time into the new repo. Then you don't initialize it and you just create repository. Then it will give you a set of instructions. I'll just show that as well. For now, let me initialize this. Okay, it just created some README file. Now I can just take this URL, new terminal. Yeah, I have the README file in that. Okay, so now we were at, so we saw git clone, right? Now we'll be seeing git status. So I can add a new file, my new file.txt. It can be something like hi, hello, okay, whatever it is. So when you say git status, okay, I need to go inside the, I keep missing this. Okay. If you do git status, it's showing you are on branch main. Your branch is up to date with the origin main. Okay, origin in the sense the from where you clone from. That is the origin, right? Like origin destination. That is the source. Your source has a main branch and it's at this commit level, and you are at your branch is up to date. Your branch in the local laptop or system is up to date with the origin branch. That's what it's saying. Okay. And why is it saying that we made the change already, right? So why is it saying it's up to date? Because it has some untracked files. Git is not able to track this file or these changes, right? That's why it's saying git untracked files. So for git to track this file, you need to add that. Okay, you need to do git add my new file.txt. or you can just say, if you have multiple files, you can just say git add dot. Okay, anything works. Okay, if you say git add dot, whatever files are present in that particular demo folder, all get added, all get tracked. So when you do git status now, so it's saying the message changed. Okay, it changes to be committed. There is a new file. It's tracking this file now, so it knows that it's a new file. Okay, and once you changes to be committed, right? You need to do commit. To commit any changes, you have to do git commit. You need to add a message, like what is that commit regarding. A welcome text file is added, some message. Okay, in best practice is you need to be as descriptive as possible, so that whenever you go through a commit log, you can know, okay, this particular commit is having this change, this particular change. Okay, git commit -m. So what is saying, one file is added, two insertions are done because there are two lines, and created a new mode. um, you can do just git push origin, or initially when you do git push, you need to add origin, but I have already added my origin as the uh, this particular repo. I'll show you how to add origin. I'll just do git push for now. Okay, so it just pushed that file. So I have my new file.txt here. So what we understood here, when you add anything new, git says it's untracked files. For git to track files, you need to do git add. Okay, once it's added, git starts tracking the changes. Okay, so now let's say I do by, okay, here in the new file.txt. If you do git status, it doesn't say new file, but it says it's modified. Okay, and that particular change, it's not tracked again. Okay, so you need to do git add, see again git status. Okay, it's modified, it's not new file, it's modified. And when you do git commit, um, a line is edited or added by, okay, git status. Okay, what it's saying, it's you just need to git push to publish your local commits. The working tree is clean now, and say git push, and your changes are here already, right? So these are basic commands. You need to know git clone, git status. Git status basically tells you what the status of your local repository is, right? In git add, this is used to track files, and git commit to commit the changes. Okay, git push to push those changes from your push those local commits from your local system to the cloud repo, whatever it is. Okay, now git pull. Let's say if I have um, if someone changed something from their repo, and they said um, okay, right, commit changes, right? So there is another change. You don't have that change in local, so you can just say git pull. Normally it's git pull origin. Since I have already configured my origin, it's I don't have to add that. So git pull. Now it's saying uh, see origin main. I have, there is a fast forward. I'll tell you what this fast forward is. There is a new file, and one file changed, one insertion. One insertion because OK is added. So now OK is here already. So when you want to push, I mean, pull any changes in the cloud repo into your local system, you do a git pull, right? Normally, typically when a employee works in any enterprise company and they are working with repos, so when they log in, they do git pull because they want their local system to be updated with all the changes and get started with the day. And once git pull is done, they'll start making their own changes in the local system. They'll keep committing the changes periodically, and yeah, it goes on like that, right? So these are the basic commands. You have seen what untracked means, what modified means, and what staged means, in the sense when you add any change, it becomes tracked. That is nothing but staged. Yeah, I hope this is clear. um, yeah, two ways to start a repo, as I've shown. Here I have initialized the repo using a readme file. Okay. uh, if I have code already here, let me create another folder, not here, but it's okay. I'll just create here and move it. Mm, demo 2. Yeah, I'll just move it. So now let me maybe, yeah. So this particular git demo 2, the folder, yeah. This folder, it doesn't, it's a new folder in my local system. It doesn't have anything to do with git. So ls-a, there is nothing in there. Okay. So how do I have my code, everything here. Okay, let's just say there are some files again. My file dot txt. This is my file. Okay. Okay, that's there. Now I want to push my application or my file into the code repo. How do I do that? So you need to do git init, or you need to go here, uh, create repositories, new repository. Just say git. So yeah, since I already use this name, it's saying like this already exists on this account. So don't do that. Okay, this is available. Now I'm not initializing it. I can just do create repository. So it creates a placeholder here, and it gives you a neat explanation, right? If you are trying to create a new repository in the command line, do these. If you are trying to push an existing repository from the command line, do these. Okay, now there are some interesting commands for you, right? I'll go through this remote add, origin, all that now. So git init, what it does is it will initialize the repository in our local system. Earlier, when we created the first demo, we did initialize it by checking on that box by creating the readme file. So when you do ls-a before, you didn't see any files, right? So let me do that again, because there is a file we added, myfile.txt. It's the only file. So if you do git init, okay, it's what it's doing. It's initializing an empty git repository in this particular folder. Now, if you do ls-a, you will have a .git folder. Okay, in that folder, let me just ls.git. Okay, you have several folders again: branches, config, description, head, hooks, info, objects. When you start doing these commits and all, there will be a logs folder as well. Okay, so all the git information is stored in these folders. Okay, now you can do git add. So status. Okay, you have added the and okay, first I committed the change, and I need to push it to a repo. Now, if you do git push, normally what happens? It's confused, right? It doesn't know where to push, because this is a repo which we added in our local system. We didn't put any links like, okay, you need to push it to particular account and particular repository, right? So it's kind of confused. So you need to tell which branch also. If you do git branch here, it's saying master, but we want our branch to be main. So what you do is you are modifying it to the it's adding this 200 thing. Just a second. Yeah. Now if you do git branch, your branch is renamed from master to main. Okay. And this is what I told you about remote add origin, right? So in the first repo, when we initialized it using a readme file in this one, uh, we didn't add any origin because when we do a git clone, the origin is already added by default. But here we are doing in a reverse manner. We are creating a folder first in our local system and we are pushing it to the cloud repo. So you need to tell this line basically tells Git where to push the files or whatever code you have, right? So that is this one. So now Git knows, okay, if I am asked to push changes or pull changes, I need to refer to this particular URL. So now you can do git push. Yeah, normally if your origin is not known or there are several other origins, you have to mention it like this -u origin main. If you do git push, see it's saying, see I don't know which upstream you have set, so git push will not work. So you have to give all this. Yeah. So this is my file, my second change. So git add. Yeah, see, from the second time, you don't need to add this because you have mentioned -u here. It's setting the upstream. Basically, -u is the short form of -- set upstream. So if you don't do -u here, git push origin main, you have to keep giving origin main every time you push a change or pull a change. Git pull origin main, git push origin main. So if you don't want to type it, you just set the upstream by using -u flag. Okay. This is okay. I'll just refresh this. Now you can see the repository and all. This is the two ways you can create a repo. Anywhere, even in GitHub or Git, you need to initialize the repo. You need to set remote add like origin from where or to where the changes need to be pushed or pulled from. Okay. And you can start using that Git. The only thing is with GitHub, if you initialize it directly, it will do all that remote add origin, git init, everything for you. But if you want to do manually, then the second way is to go. Yeah. Now we'll look at branching and merging. We have earlier when I was telling why Git is needed, we saw a feature thing, right? If anybody wants to add a new feature, they can create a branch and then a feature branch, and they can start working on their changes. And once that changes are done, they can just push those changes to the main branch. So how does it work? So in this diagram, every circle you see here is a commit. Okay, it's a change commit. So this is a main branch. So you can create a feature or multiple features from a main branch. Okay, you can name it as you like. And in the case of feature 2 here, this feature 2 branch here, the base commit becomes this one. So your feature 2 will have all the changes before the base commit till the base commit, and then it will diverge into a different branch like a tree, right? So yeah, merging, I'll talk about this. Let me just show you how you can create a feature branch. There are two ways. Again you can do it from GitHub or you can do it from Git CLI. So I don't see the branch create branch option here. The branch. Let me create a new branch. Source is main. See, if you want to create a feature, yeah, if you want to create a feature from a branch, you need to mention its source. So if there is a feature branch and you want to create another branch from here like this, then you have to mention source as feature2, right? So since we have only one branch, we are just selecting that. So let's say feature1, or let's say 2. Okay, just create a new branch, and you have that. So when you go here, you will be able to see the feature. To pull those changes into your local, you need to go git pull. Okay, so now it's saying, see, there is a new feature branch that was added. I'm pulling that branch into your local system. So let me just try this. So ls.git branches. Okay, it's not ls-a maybe. Okay, so you can uh, pull those branches like this with git pull command. And if you look at which branch you are right now, when you type in git branch command, it will show you on which branch you are, right? So, and the star in, okay, I'll just show you this. If you, yeah, you pulled in this feature2 branch, right? Now you want to use that branch. How do you do that? You can just say git checkout this origin slash feature2. It should auto populate. Yeah, good. Yeah, right. So it, when you type in git branch again, head detached at origin feature2, or it should be at origin feature2. So you don't have star on the main branch now, because you switch to a new branch, and it's at it's indicate, star basically indicates among the branches you have, where you are at, where your code is pointing at right now. Okay, let me just create a new branch from local here. If you want to create a new branch, you can say git branch -b and then feature2. Okay, and oh, you need to specify a source for it. Or you can just do from here, new branch. From feature2, I want to create a new branch. Okay, branch name. So there is a feature1 again, and feature1's source is now feature2. So when you do git pull, a new branch is added. You can do git checkout origin feature1. Okay, so if you are confused in console, like what's happening, and you want a clear like graph kind of thing, there is an extension in VS Code called um, extensions git graph. It's developed by someone. It's not a company that's doing it. So if you do it, you can just see all the commits. You see origin. As you keep committing changes and all, it will populate nicely. So if you are in see all the commits are visible properly. We will see these changes going forward. I'll just show you that. Right, you are on feature2, feature1 now. We did manage to count change. Yeah, switch to new branch. So -b is needed. I didn't give that. That's why it was saying that you didn't check out it. You are just pointing your head to that change. Okay, so the command is git checkout -b and the feature name or branch name. Okay, So when you do git branch, you can see the branch being highlighted because your code is pointing to that branch. If you do feature 2 git branch, so it's adding that list. See, and star is being pointed to whatever your code is pointing right now. And okay, fine. Um, if you want to delete a branch, right? So what you do is git checkout -d origin feature 1, right? Git branch -d. Yeah, so git branch -d origin feature -d is for delete. So when you want to switch branch, git checkout -b is the command. When you want to delete a branch, git branch -d is the command. So if you do git branch right now, uh, you will see that feature 1 is deleted, but it's okay. Git checkout -v, and let me just go to main branch. Yeah, and you have these. You can do git status, everything is clean. But when you refresh this, you will still see the feature branches here because these commands are being run in local. You are not getting these changes reflected here. Fine. So that is branching. Like you can have different branches. Okay. I didn't make any changes, right? So yeah, sorry. Origin slash. So now we are in feature 2. This is the file. I'm in feature 2 now. Okay. Git status, git add the file, commit, added branch name in file, git push -u origin main. Oh, did I push to origin main? I am in the feature branch, right? So I made a change. I added it and I'm trying to push it to the main branch. That's why it see you are in a feature branch. You can't push changes directly to the main branch. That's what it's saying. So what I'm doing is I'm making another change. No, pushing that change to feature branch, and it's not. Okay, 1 second. Yeah. So if I refresh this, remote and then branch. Okay, I'll fix this. So anyway, we have hit 1 hour mark. Let's take a 5 minutes break, and I'll get back with the branching, the issue fix, and what happened exactly.
Yeah, dear all participants, please don't leave the meet. Be there. You can take the break, but be in online.
Yeah. So let's get back to this. So I'm in future to now, making a change. I'm just making a change in this particular file. Okay. So we will add this change. We are on feature 2 branch. Okay. Git add the change, commit the change, my new change. And while doing git push, since you are on the branch feature 2, you need to mention it. So how can you mention it? Git push origin slash feature 2. So when we are on main branch, we need to we have mentioned -u, right? We have set it by default that we are making changes to main branch. That's why it's thinking that this particular change is being made to main branch, though we are on feature 2. So that's why we have to specifically mention that git, I'm making change to this particular feature branch. So when you do that, it successfully pushes to that particular branch. And okay, if you can refresh, I'm on main branch, that's why I'm not able to see this. So feature 2, this, I'm in feature 2 now and making a change. Okay, so and you can see something called compare and pull request here. We'll talk about that, but basically branching is like you are taking a copy of your main branch. So basically this commit, and you are diverging into your own tree to make your own changes. And this particular commit will not disturb the subsequent commits made on the main branch. If you want these commits in your feature branch, there are several ways to do that. We'll see that. But this is how branching works basically. You need to mention a source, and when from that particular commit, you will create a new feature branch. So when that is branching, and if we talk about merging, uh, now let's say I'm in this particular commit, and I want to commit my changes to the main branch. How will it be done? When you do, there are two ways to do it. We'll see it in the next slide. But essentially, when a merging action is performed, it will just take the, it will do a three-way commit by default. What is three-way commit? It will take the latest commit of the main branch to which it is being merged, like the destination branch, the source branch latest commit, and the base commit of the source branch, right? It will compare all these three, like how many commits have been made since the feature branch was created, what are the latest commits, so what are the changes in both the files. It will do a three-way comparison, and it will intelligently decide if there are any conflicts. If there are no conflicts, it will just merge it. So, and it will be this will be like joined into the main branch only. So we have seen git branch command that is used to switch branches in your local system. We have seen git checkout. uh, Git branch command, it can be used to create or delete branches. Git checkout is used to switch the branches. Git merge and git diff we have to see. So let me just go over there. So git diff main. So git diff is a command that will show you the differences between your current branch and the branch which you are mentioning as parameter. So now you are in feature 2 branch and you want to compare it with the main branch. So what are the changes or what differences are there? So it will just give you on the terminal like this. Okay, this is the new change that is there. It's the same as the one which is shown in the UI. When you see it compare, so you are just removing this line. You have added these two lines. That are those are the differences between the main branch and the your feature branch or current branch which you are in. Okay, so if you want to merge this feature branch to the main branch now, you can do it from GitHub, like compare and raise a pull request. Okay, or you can do it here itself from the command line. So you need to go to the main branch first, git merge origin feature 2. Okay, now it's merged. So in main branch also, now you are in main branch, the star is pointing to the main. You can see the I'm in feature 2 and now I'm making a change. So the changes that were there in the feature 2, they are now available in the main branch. Okay, Yeah. So that is git merge and git diff, right? So, and the next one is merge conflict. So let's say there are two files and same files, and in the same file, both two developers are working, and in these both commits, they are changing the same line in the same file. And when you do git merge, which change does the git keep and which change does it delete or override, right? Git can't decide that, so it will throw a merge conflict error. We'll see that. So I'm making a change here, and this will be a main branch because this is a main branch. It shouldn't be feature 2, right? So this is main branch, and git checkout origin feature 2. Okay, so switch to origin feature 2. Let's say feature 2 now. Git diff main. So as you can see here, uh, both changes are in myfile.txt. Yeah, and it's saying I'm in feature 2, and this is being removed and this is being added. So let me just check out. Okay, I need to add the changes. That's why it's not showing. Git add dot git commit hyphen m made some change here. Git push origin feature 2. Fine. Let me just go to check out main. So here the change which we made was removed because we didn't commit it. Git add git commit hyphen m made same line change for merge conflict. Okay, git push. So when you do git diff with origin feature 2, you can see that one is showing that I'm in main now, the other one is showing I'm in feature 2 now, right? So when you do git merge, you are in main branch and you are trying to merge the feature branch here. So feature 2, see, it's throwing a conflict. These are because we are changing the same line in the same file. It's asking us, so which changes do you want to keep and which changes do you want to remove? So you need to decide what to change. I want to remove the feature line. So resolve in merge editor, or you can just, this is a small change. I can just go and remove this. I don't want this. Okay, so I'll explain what this is. It will give you these weird characters, right? This is the current change, and this is in the head branch, in the main branch. So in feature, this is the change that is incoming from a different branch, and that is from origin feature 2, right? So you need to remove all these lines. I just want to preserve this particular change, so I'm keeping that. I'm removing everything else. Okay, and right. Okay, I need to add that change. Merge conflict resolved. Yeah, it's already merged. Okay, so if you, even if you do that, it says it's already up to date. There is no change now. Okay, so An event that takes place when Git is unable to automatically resolve the differences in code between the commits. Okay, resolve the conflict manually. You need to add and commit the changes and merge it. So any questions till now? Did you guys understand everything? Do you want me to repeat something or you don't understand anything at all? If you can speak like what you want to be repeated or what questions you have, I can answer them. Okay, so let's go to the next thing then. Undoing the changes, right? So I'm adding change to undo, some change here. Okay, I added it, but I didn't want to add this file, track this change or track this file. So I don't want it to be tracked. How can I do like undo it? It just suggests that, right? So git restore. So for every stage, git reset command or restore command can be used. Okay, so git restore the file name. So if you do git status, I reset. Yeah, unstaged changes after reset. To do git status, it's back to untracked change. So that is here git reset filename.txt, and it will bring back your tracked changes to untracked state. Committed changes. Let's say if I added this, if I committed this, now git status. The change is not visible, but I didn't want to commit it actually. So what you can do is you can execute this command git reset head underscore reset head. This is a tilde command. One. Okay. Now you do git status, you have it back again, right? So in the git reset command, the head indicates the latest commit, right? It's the latest commit which you have. So you're basically resetting the latest commit. That's what it means. And every commit that you make is stored in git log. Okay, so every commit is associated with the hash, and when you say head reset, it's basically see, it's clearly pointing this as head. So you when you do git reset head tilde1, then you are basically resetting this particular commit or change. Earlier when we had merge conflict, it printed some things here, right? It asked us to resolve conflict manually. So what it did is it's doing that merge. When the conflict arises, it is putting a hold on that action, merge action. So until we resolve it manually, it was holding it, like pausing it. Once the change was resolved and we added that resolve conflict, then it went ahead and did the merge, right? So if we, when there is a merge conflict and even you are not able to decide which change to keep and which change to discard, then you can do a git abort. When something is on hold, see git merge hyphen abort, that will revert the merge command basically. Okay, so yeah, and there are, you might have heard of something called fork. Clone, we did a git clone from our terminal, right? From git repo, when we went here, you have these commands, right? This is basically clone. But what is fork? Fork is something that will that allows you to take someone else's code, right? Clone, it will only allow you to clone public repos or something like that. But fork allows you, when you do clone, right, you basically copy this entire thing into your local system. But fork allows you to copy someone else's GitHub profile, I mean, or that code repo into your account. I can go and see some Prometheus GitHub repo. See, this is the Prometheus public repo. What I can do is I can go and fork it. See, you can see it's already forked like this many times. I can just do create a new fork, and I can bring that into my own GitHub account. So I can have my own branches. I can have my own features and all that. When I'm satisfied with any changes, see, I'm using this particular Prometheus to monitor my applications. I saw some bugs, so I forked that repo. This is a public repository, it's open source, right? Its forks are welcome and pull requests is also welcome. So I fixed that particular bug, and I can raise a PR, pull request, to this particular original Prometheus repo. See, there are already pull requests, 179 pull requests. So some people fix these issues and they raise a PR, so that the admin of this Prometheus, they can see the changes and they will approve that pull request. So a review is required, right? So the reviewers will be there. They will see, okay, is this guy really fixing it, or is he doing something else? Okay, they don't want unnecessary changes to be committed, right, to the main thing. Once they do all the thorough checks, they will approve it, and that particular change will be made into this particular main Prometheus code repo. That's how it works. Even in here, if I made some change in my feature 2 branch, okay, so let me just do this. So I'll remove this, commit changes, commit to feature branch, okay, in code, compare and pull request. This is basically one way to merge your code into this branch to branch. So it's, the arrow indicates that from feature you are committing to main, create pull request, okay. See, there are conflicts again. It raised a merge conflict. So resolve conflicts. It's the same thing again we are doing in editor now. I'll do this, mark as resolved, commit merge. Yeah, this is done, and your feature branch changes are ready, and you can merge the PR, confirm merge. So it's pulled, I mean pushed, your changes are pushed into that. So that's how this fork works. So these are the differences. So local copy created on local machine, but this is fork is an independent copy created in your GitHub account. You can push or pull changes using git commands. There are no commands. It's a UI based thing, right? This is commonly used for own projects, but you can copy someone else's projects. Merge can be done using git and PR. It can be done only through PR because git is a command line tool, and you don't have command line facility here in fork. So we have looked at git status, git clone, git push, git pull, merge, diff, all these things, right? There are several other things, and these are quite advanced. The advanced concepts need to be used only when you thoroughly understand what you are doing. Okay, if you don't understand and execute these commands, it can mess up entire code base. So cherry pick. So let's say there is a main branch, there is a feature branch, and several commits in that feature branch, right? So let's look at that commits. One is a bug fix. The second one is some new feature is added. The another one is another bug fix. So the main branch guy, the admin, basically what he wants, okay, he sees this feature branch commits. He's very interested in the bug fixes because that's really a critical bug and that needs to be fixed. But he doesn't need this new feature. Okay, he just want the bug fixes. What he will do is he will just cherry pick particular commits into his main branch. So you can select a particular commit and you can pick that change into your branch. Cherry pick is used to select and merge specific commits from different branches to your current branch in the order specified in the command. So the command is git cherry pick #1 and #2. You just saw the hashes here, right? Git log. So this is the hash. If you want this particular commit, you should say git cherry pick this hash, and it will do that cherry pick. If you have multiple commits that you want to select, you need to give all those with space as a like delimiter, and then it will cherry pick those changes in the order of your specification, right? So that's cherry pick, and this is rebase. When you do rebase, when you will do rebase means there is a main branch. You created a feature branch out of it, and the base commit is this one, right? Uh, but you are on feature branch and you want these two changes as well from the main branch. So what you will do is you will do git rebase so that um, your base commit becomes the latest one. So that will be the base commit, and your feature branch will be pointing from there, not from the second commit in the main branch. It will be pointing to the latest commit. So it's very it's a command that can destroy everything, because if the in the feature branch initially the hashes for these commits were #1 and #2, let's say, but when you do rebase, these hashes change to something else. So in your system, the hashes will be #3 and #4, but in other system, when you they will be having your commits as #1 and #2. So there is a discrepancy between your local copy and the other copy, uh, because the commit hashes have been changed. So use this only when you think it's needed, right? How much is the time? 15:30. I can just show you this rebase command in practically. So let me just in my file.txt I can just make some uh, changes. Rebase demo. Okay, commit changes. Commit, right? So this is committed without note. Git branch. Okay, I'm in the main branch. I don't have the change which was done earlier. So I'm doing my own. Okay, I'll just add one more file so that I don't have a one more file. Okay, one more file. Okay, I don't have the new changes. I didn't do git pull. I'm just adding my own changes. So I'm adding my own commits here. Name, one more file. Git push. Right? So this is rejected. Why? Because there are some other changes in the main branch, but I didn't have those changes in my local. I added one more change and pushed it. There is a mismatch. So what is it asking? It is asking you to pull the changes first. So when you do git pull, it says, see, there is some other change in your system. You need to do a rebase. So what you need to point your new change or commit to the latest uh, commit of the main branch. So when you do git pull, you need to do git pull rebase. Git status, git add -m, change, git push origin main. It's rejected. So see, the git graph is now, since we did multiple merges and all, it's populating very nicely. But let me just pull the change here. Oh, it's raising a conflict here because it's in the same thing. Yeah, I'm rebasing from the main branch. Do this to add. Okay, interactive rebase is in progress. Rebase, continue. Yeah, successfully. So rebase was on hold because there was a merge conflict. And once the merge conflict is resolved, I should be executing this rebase continue so that that operation is completed, right? So that's why it was throwing these errors. So interactive rebase in progress. So you need to continue this before you do anything else. So that's rebase. Rebase is used to change the base commit of your current branch so that you can have these commits into your branch before doing further changes. So there is something called git fetch. Okay, fetch is nothing but a subset of pull. When you do git pull, you're actually doing git fetch plus git merge, right? So it's a combination. Git pull is a combination of git fetch plus git merge. And in git pull, as you can see, I did git pull hyphen hyphen rebase. In pull, there are these three options. Okay, when you do rebase, git pull hyphen hyphen rebase, what it does is the feature branch is pointing to the base commit, and the base commit is not the second one; it's the latest one. It's the same as the rebase concept earlier. This is fast forward. Hyphen hyphen ff is fast forward. So what it does is it will just merge the latest commit to the main branch when you do git pull. So fast forward only, what it does is whenever there is no change in the main branch, it will pull that feature branch's change into the main branch. If there is a new change here, ff only will not work. It will throw a resolve conflict. Even in merge, there are fast forward options. You can do git merge hyphen hyphen ff or hyphen hyphen ff only. When there are no changes in the main branch and your feature branch is like ahead in commits, it will just absorb the feature branch. So it's basically the same thing. When there are no changes in the main branch and your feature branch is ahead of the main branch in terms of commits, it will just absorb the feature branch into the main branch. That is git merge. So when you don't give these commits, depending on the scenario, if there is a new change or if there is no new change, Git automatically chooses the options or mode based on the scenario there. So there is something called Git stash. What so when you did changes and there are some other changes which are there in the main branch, in your local copy you added some changes. In the main branch there are some other changes. So and your local changes are not yet complete. You don't want to commit them right away. So you don't want to do a rebase. So what you will do is you can park these changes into a separate queue. Okay, sorry, it's a stack. So when you do git stash, it will park those changes into a stack, and you can pull the changes from main branch into your uh, local. Okay, once it's pull is done successfully, you can do a git stash pop. So these are the commands that are used for git stash. When you pop these changes from the stack, you can entirely move these changes into a new feature branch as well. So git stash branch and the branch name, it will create a new branch for you, and it will pop those unfinished changes into this new branch. The index is basically if you park multiple changes in a single stack, they are stored like a data structure items. So they will have their own index like 1, 2, 3, 4, something like that. So you can have multiple elements in the stack. Each element will have its own index, and these can have custom name as well. You can name the stack using -m. So popping an element from the stack will bring those changes back. You can create a new branch with the stashed changes as well. And there is another command called squash. If there are multiple commits, small commits, big commits, the log is very huge and you are very confused. So what you can do is you can merge all those commit logs into a single commit log, so that it's clean and you are basically not confused with the unnecessary commits. And we'll be looking at branching strategies. Whenever a company starts using Git, they'll adopt one of these strategies. One is trunk-based development, where there is a main branch and people will create a feature branch, which is basically short-lived. They'll add that feature and merge it immediately. So it's like 1 week or 1 day, something like that. Okay. This heavily relies on automated testing and continuous integration, because you're not maintaining this branch longer. You are doing changes basically to main branch immediately. So main branch, any changes that go into the main branch need to be tested. So that's why it relies heavily on automated testing and continuous integration. And the next strategy is feature branching, where you have several features. Each developer basically creates their own developer or DevOps person, whoever is dealing with that code. They create their own feature branches and they have several commits. And once in a month or when they have a release, they'll do these merges and they'll release that feature. Okay, so any changes so far till now in Git? We are moving to GitOps now. All right. So what is GitOps? So let's say there is a server in some company. There is only one server maybe. It is easy to manage. Like you can do patches, log into the server, do patches, track the changes. It's not an issue. But when there are multiple servers, then that starts becoming a headache. So typically when the company grows, there will be multiple servers and they are wired as a cluster. So cluster is basically a group of or pool of servers, they'll call it. Okay. So as a company grows, there will be multiple clusters as well. Okay. Now, if you don't have any way of tracking changes, it really becomes a headache. Who did what? Did we do patching in this cluster or in this particular server in that cluster? Or where are these vulnerabilities coming up? All the management becomes a headache, right? So what they did is they converted infrastructure as code. Every change or creation or deletion, whatever it may be, patching, everything that needs to be done on these clusters can be done through code, like Terraform, Helm, any of these, right? The infrastructure as code is the term given for that. Similarly, several concepts evolved, like security can be written as code, right? A network can be written as code. Policies, any policies like permissions, access roles, all these things can be written as code, like JSON files or YAML files, uh, right? All these patterns emerged recently, and they are called as XAS code. Basically, they are termed like that. Okay, when everything can be written as code, these all can be stored in Git again, right? So now what happens? You have all the configuration files like IAC, even server files, everything you have stored in Git. Okay, in Git again you can apply these. There is a main branch. If someone wants to add a new server or do a patch to that server, they'll create a new feature branch from that main branch. Uh, that commit will trigger a CI pipeline. which I showed in at the start of this session. It will do all the tests like unit test, like is this syntax correct? Is this breaking something? Basically, testing is done. Once that testing results are out, someone will have to approve that feature or change, and it is merged into the main branch. And once it is merged into the main branch, there is a CD pipeline that's triggered. Okay, what CD does, it will deploy that change into the environment, right? So it will deploy that into your cluster. Basically, let's say the cluster is a Kubernetes cluster, and the CD pipeline has two ways of applying that change into your environment. One is a pull based change, and another is a push based change. Okay, so pull based change. So cluster, this push or pull is in the perspective of the cluster. So when a cluster needs to pull changes, it will have some agent, some sort of agent like Argo CD running inside that cluster. Okay, and it will keep monitoring this particular Git repo in the main branch. Whenever a change is merged into this main branch, this particular agent will pull that change and apply it in the cluster, right? So push based means CD pipeline will only push the changes. But in terms of GitOps, Argo CD and Flux CD are popular, tools that are famously using pull based deployment. So GitOps is a method of managing infrastructure and application deployments using Git as a single source of truth. If you look at this particular flow deeply, you will understand that nobody is allowed to make changes directly to the cluster. See, if someone logins to the cluster and makes some changes in this particular server, this particular agent, what it does, it will compare the state of the Git and its state of the cluster. So it will quickly identify the difference. Okay, but there is a difference in this server, but it's not mentioned in Git. So I need to make Git as the, it will just copy the changes in Git, and it will override the changes made here. So if someone hacker hacks into the cluster and does something, this agent, what it does, it will just revert all those changes. And so hacker is kicked out. His changes do not apply because it's not matching with the single source of truth, that is Git repo, right? So the only way for employees or any resources working on this particular cluster to make any changes is through Git, and Git keeps track of what changes are made and who made those changes. That's why it's secure, it's reliable, it's a single source of truth. That's why you can't make any changes here directly. So you have log of everything, you keep track of everything. So yeah, any changes in the cluster means changing the actual state of the environment. The agent, as we saw before, periodically compares the states with Git. Since the changes are not there in Git, it will change the actual state to match the Git. This is what I explained before. Git is the only way to make any changes. It's simplified deployment, increased reliability. Even if someone makes any change in Git that breaks this cluster, since you are having a list of all the commits, you can just revert back to the previous change, and your cluster is back up again within seconds or minutes, how fast you do a rollback. So you have that faster, reliability, availability, auditability in the sense who you are tracking, who is making what changes. So security, as I said, hacker, if he hacks into the cluster and makes some changes, that's not approved because Git is the only way that you can make any changes. Faster iteration, people can start working on their own features and they can push changes to main. They are not stopped by someone doing the task. They can create their own feature branch and do things. So that's it for today. Any questions you have, please speak up. So the session tomorrow will be on microservices and containers. So that is basically why microservices are needed and what is Docker, how Docker works, what Docker image is. I showed you in the session today when we started, how we are pushing images to Docker, right? So that will be covered. So any questions if you guys have, I'm happy to answer.
Yes, to all participants, I have sent a attendance link to your mail. Just check and put your attendance too. So yesterday I have shared the recording too. And similarly, I'll share this recording for your practice. Once the recording is prepared, so you can practice also. So if any other doubts, students, just raise it.
So with this session, I hope you guys are having an idea of what Git is, why it's being used, what advantages it has, and you can start creating your own GitHub account. Git install Git locally, create some files, play around like what I showed in the demo. Even when I am doing things, I messed up few things. I read the errors, fixed it. So that's how you learn. You play around with things, break it, fix it, and then learn it. Yeah, ma'am. I think that's it for today's session.
Okay, sir. So I'll share the recordings anyhow to them, sir. So at the time they may do practice. So they can get an idea at the time. Yes, sir. Okay. So I declare the second session is over, and I request everyone can leave now, and we will meet tomorrow by the same time. And thank you to our resource person and to all participants. Thank you.
Yeah, thank you, ma'am.
Thank you, sir. Thank you.